of course, bringing in the renewables, you can solve that equation. It's amazing. In particular, since many countries in the world are below the 2 tons per capita per year still, like India, for example. India is going to be the biggest population in the world in the next 10 years or so, 10 or 20 years, and they are actually below that line. Now, if the Indians would say, we do not imitate what Germany or the United States or UK did in history, we try to stay below that line, and we will sell the carbon credits in order to have a lot of investment in our country, so it would be emissions trading system. And this could be an extremely smart move. I mean, I tried to convince the Indian government of that. It's very difficult to do that. Actually, I mean, this is something which should not go sort of into, I mentioned Albert Einstein before, and, you know, Mr. Ramesh, who is the former environment minister of India, before he became a politician, he wanted to become an astrophysicist. And he visited me in Potsdam and looked at on our fabulous sort of telescopes and experiments. And he was very much in favor of that scheme. Unfortunately, the Indian government sacked him for that and replaced him with somebody who is sort of going the old way. But I'm pretty sure in the end people will wake up. So the take-home message is, if we want to keep climate change manageable still, every person on this planet, on average, of course, over the next 50 years, has to consume no more than 2 tons per year. And you make your choice how you want to use it.
Yes, there's a gentleman in blue, and then...
and by the way, this is not politics, that's physics. I have no problem with
that. Let's take more than one question at a time, just 2 or 3, so we can answer that. Well,
yeah.
3 for now. Go ahead.
Okay. Hello. Yes. Thank you, Professor Schellnhuber, for giving us this opportunity to discuss this very important issue. And I've been gratified to see recently how it's really developed a momentum of developed a large contingent of people who are beginning to be aware of this, who do accept the fact that global warming is in fact a fact and is a problem that needs to be dealt with. However, there is the other side of this issue. I saw recently this very good documentary film presented at the Dubai Film Festival called Surviving Progress. I don't know if you're familiar with this film.
No, I haven't seen it.
But in it, the point was made that most of the Earth's wealth is either possessed by or controlled by 10% of the people. This is this ruling oligarchy of the super rich, and like they have, of course, have made their money by selling us things like the consumption of fossil fuels. And as any good drug dealer, they want to keep us addicted to this. It's not in their interest at all to have us develop other energy sources. They don't care about future generations, obviously. They want to make the profit now. So do you not share this? So in fact, since they do control the technology, the military-industrial complex, research, I see.
Can you please make please have a question, no comment, just a question.
I see it's kind of almost hopeless to expect that we can wrest control from them or the money necessary to do the research to get ourselves into a renewable energy sources. Do you not agree with this, and do you have any solution toward this?
No, thanks.
Okay,
I have an answer
hold
to
for
that.
a second. The gentleman over there, please.
Well, my question is, thank you very much really for the very stimulating, very interesting calculations and very nicely presented. But I would follow on the question which was just given. Looking at your curves that we need 2-3 years if we want to peak into 2012, and 2020 is almost a deadline, and knowing at present that the European Union has to deal with the financial crisis in the next 5 years, hardly they will have time to think politically about this, and the world has a lot of other issues. We are on the red curve. I think we are well under the red curve. We are gone. I mean, how we are going to do it? How long it will take for Germany to demonstrate the thing? It will take another 10, 20 years until there are the real results. Well, can you comment a little bit?
Yeah,
or we just prepare ourselves for the red curve? As simple as that.
I just want the lady over there, please. And keep it short, short comments, because we will have to wrap it.
I'll answer the 3 questions now, but I'll take this one, yeah.
Hello. Hi. Thank you so much for your lecture. I'm just going to ask you a direct question. What do you think about scientists collaborating with artists to come up with creative solutions? Because honestly, I don't think that scientists are creative enough to face these challenges alone. Thank you very much.
Okay. You have to make a comment on that.
Oh, okay, I won't make a comment, but I will just summarize. You were asked here to do a couple of things, to talk about the interest, greed, Eurozone economic crisis, and the lack of artistic creativity. Please go ahead.
Yeah, I leave the answer to the last question to Micheline here. So I just duck the question, which is a nasty one, of course. But the first 2 questions are related clearly, yeah? But you brought in the aspect of, of the financial crisis and things like that. Now, the good and the bad news is that the human enterprise and the energy system is a complex system. And in complex systems you have these nasty characteristics that you cannot predict them, you cannot easily control them. You know, but you have also what I call, what is famous as the butterfly effect. You know, the butterfly effect says the wings, flapping the wings of a butterfly somewhere in Hawaii could create a hurricane over New York because of the nonlinear amplification. What makes the system very unpredictable, but it also means you can have an amazing leverage, if you like, of certain things. So that is in particular for this question. Now, again, just going back on the empirical evidence. Now in Germany, 15 years ago, an instrument was introduced by members of the Green Party, actually, when they were the minor coalition partner with the Social Democrats, and it's called the feed-in tariff. The feed-in tariff means you will have a guaranteed return on your investment if you invest in photovoltaics or wind energy, things like that. Now, if you ask the economists whether this is the smartest instrument for innovation, they will tell you bluntly, no, you can come up with much better solutions. But just waiting for the best solution to be implemented and just watching time goes by is not a good thing, in particular when we think about this 2020 peaking. So it was just introduced as a second or third or fourth best solution, and it was completely taken off and has changed. If you now look at solar capacity being installed, it's in the gigawatts area every year, so it could replace dozens of nuclear power plants. So sometimes, instead of just calculating the optimal solution, you just have to have a move. And you have no guarantee that it will change the system because of the nonlinear amplification effects. It will change the system entirely. Now, as a scientist, I would say you have to do a dozen of these experiments, social experiments, and most of them will fall flat, but one or two of them will come through. And this is, you know, there is this famous saying also, the Stone Age didn't end because we ran out of stones. Stones were simply replaced by a superior material. it was bronze, and later on you had iron and things like that. And I do believe we have better things when even fossil fuels, although the fossil fuels have a fantastic energy density. I mean, it's no accident that our industrial revolution is based on them. But we have an alternative. So what I would say, the nascent science of transformation tells you that you have to, if you like, create a portfolio of seeds of innovation, like if you have seeds on a field of wheat, whatever, and some of these seeds will really turn into a full plant. And this is all you can do in a complex system, really. But the worst thing you could do is say, because I'm not sure whether this plant will thrive, I will have no seeds at all. And that is the situation we have right now. If you're not sowing, you cannot harvest.
Is there one more question?
Can you answer the lady's question?
Well, it seems to me that the gentleman who described the retrenchments of Europe,
the financial crisis,
the retrenchments of the financial crisis.
Okay, let me say a few words about the financial crisis. I mean, we tried to convince, I mean, we scientists, but also advisors to government, that the best way to overcome the financial crisis is precisely investment into infrastructure. By the way, that is probably the best way also to pull the United States out of its predicament. And if you invest in infrastructure, why not investing into sustainable infrastructure? So it's a very simple equation.
And that is as long as that is labor-intensive type of employment. So any other questions? I will just take 3, make that short, and that will be it. Gentleman here. Over here. Oh, sorry, you as well, and behind the young man over there.
Thank you. It was very powerful presentation. Thank you very much. Thank you for Khalifa University. It was very creative innovation. Thank you for the center, and thank you for Michelle also. You have mentioned one number was $1,000 to cool by technology means. My question is, if we use trees to do the same job, how much that cost? How many trees do we need? And to do this job through trees, how much space do we have on the earth to do it? Thank you very much.
Very good question.
Did you?
The young man?
The gentleman over here, I think. Just there's so many more hands, and just on the left, yes.
So,
yes, the young man here, and then, yes.
You mentioned ocean acidification, and then you also spoke about how we could build giant fans to suck up all the carbon and then keep them all. But then, after sucking up all that carbon and we just have it, what do we do with it? Like, don't we dump it back to the ocean? What could we do with that carbon?
Okay.
If you allow me, I want to answer the question of the science and artist. The combination of scientist and artist is an engineer. So we have this solved.
So long live creative engineering then.
I am engineer. I'm proud to be an engineer. Now, I have a question about the you talked to us about the innovation of reducing the sun radiation. What about innovation in consuming the carbon? Besides growing up trees, how we can consume the carbon dioxide from the environment?
Maybe I respond to the 3 questions. They are all related in a sense, and I mean the calculation with the $1,000 or so on, that was really done based on evidence we have of absorbing substances from flue gases and things. So there are a lot of data, empirical data on that, and you come up with that. That was actually a calculation done at the beginning by people at the MIT, so Haus and Herzog and other people. But it was also confirmed by a special report of the American Physical Society recently, and it was led by Rob Sokolov from Princeton. So it is very robust. The trick is, and where your trees come in, the trick is, or actually the stupidity of that scheme is, you know, having these gigantic fans and trying to remove the CO2 from the air. But first nature has created and concentrated of, say, 300 million years the energy density in oil. It was a very long and complicated process, the geochemical process. And it has condensed with energy in a fantastic way. Yeah? In a small glass of petroleum, you have so much energy. It's fantastic. Yeah? Now, if you burn it and spread it out all over the atmosphere, within 14 days, all of the CO2 goes all over the planet. Yeah? So you create the biggest entropy production you can imagine. Yeah? And when you try to reverse this entropy production and to concentrate it again, it's absolutely stupid to do that. So why shouldn't you go to the point source where you have a concentration of CO2 if you burn it in a coal-fired power plant? Now the trick really is, and so I'm very glad you asked this, if you would plant trees and just leave it to them, and it costs almost nothing, to suck up the CO2 through photosynthesis, a wonderful technology invented by nature over many million years. And when you burn the tree in order to take out the energy and sequester the carbon, and you can do it even by putting it on fields as fertilizers. So that is also the question about using the CO2. It's called terra preta by the Indians in Latin America, for example. When you would even create at almost no costs an emission CO2 sink, you could have a net removal, you have the bioenergy, and the costs are very low. And actually it was calculated, and you come up with a factor which is 10 times cheaper when doing this fan approach industrial air capture. So at least a 10-time superior technology by using biology. So on the ocean acidification, that is the big problem actually. The solution is precisely using biomass and letting nature doing that. If you would have these gigantic fans and remove the carbon, you cannot just put it back into the carbon cycle of the planet. You would have to precipitate it through chemical substances and turn it into limestone or things like that. And that could be used for building cities, entire cities. But you know, 10 gigatons per year, that's a lot of material. You have to ship it, costs a lot of energy. You could build many Abu Dhabi's with that. And I don't think this is the future of your city. And the final thing is on using CO2. That's precisely what we do in Potsdam right now. We have created an Institute for Advanced Sustainability Studies. It's modeled after the Princeton Institute for Advanced Studies, but it focuses on the problems of the 21st century. So it's really about sustainability. And one of the directors is Carlo Rubbia, a Nobel laureate in physics. Actually, he was the Director General of CERN, you know, the particle accelerator in Geneva, for many years. And under his guidance, the internet was invented. So he's a quite innovative person. And they're doing a number of concepts how to use the CO2. So if you would sequester it, you would not just tuck it away underground where people have a lot of worries about that, but you would feed it back into the industrial cycle, and you could create methanol from it or many other things. So the really sustainable solution would be you burn coal or oil and you take the CO2. Okay, final remark, I skipped that slide, but that is my favorite solution. You know, with renewables you have the problem of volatility. The wind doesn't blow all the time, the sun doesn't shine all the time, and so on. So often you have no energy at all, and often you have too much energy. Now the storage problem is really the biggest of all. Now you could imagine if you would use the excess energy from wind farms, for example, to do hydrolysis, to create hydrogen, you would at the same time sequester CO2 by burning fossil fuels, and you would turn the whole thing into methane, natural gas, if you like, when you would have the ideal storage medium, and you could use all the natural gas infrastructure you have already. For example, in Germany, you have storage space for 3 months of our primary energy demand for the full year. So combining renewables with carbon sequestration from fossil fuels would create artificial gas, and you could move it in a closed cycle. And using all the existing infrastructure, we call that methanization, and it may be one of the silver bullet technologies, actually. So in the end, my title is warranted. Can innovation save the world? The answer is yes.
On this positive note, thank you very much. I just briefly want to thank ECSSR for partnering with us, and various people who helped us organize this event: Marianne Hassan, Beth Roop, Nadine, Momen, Arij, Fatima, Omar, Abdelaziz, and if I forget some of you, forgive me. I know the people behind the curtains, the invisible one who helped us create this event. I want to thank them as well. I would like to invite, before we go to the reception, just for a minute, our president to present you something that we have for you.
You have it, right? So, just a small token of our appreciation. Thank you very much. Very stimulating. Thank you.
Okay.
Good. All right. Good. We have a reception.
Yes, and there is a reception outside, so please join us. I'm sure we want to sustain your energy by just nibbling and also talking with our guests and others. Thank you.